If you go through the solutions of those questions and the recording carefully, then you will be able to solve most of the questions that you are having in doubts. You will be able to solve them yourself. So I urge you to put some effort also in yourself to try and do the questions yourself, because it's all very fine that I can solve the questions for you as doubts, but then you don't end up solving questions yourself, right? So you have to try those questions yourself also. So let's start with some more examples of pulley-based systems. So this next example is for you people to try out. Okay. So here we are having a system like this where we have an inclined plane, but it's like a inclined surface, really more like an inclined surface like this, which is, let's say, at 30-degree inclination to the vertical, sorry, to the horizontal. This is a smooth surface. Okay. Now what we are doing is we are placing two pulleys at the two corners that you see. So there are, just a moment. Yeah, so there are two pulleys which are the standard type of massless smooth pulleys, which are fixed at the two corners like this, and then we've got threads going around them, which we are going to use to attach blocks. So this is the situation of blocks. Okay, so these blocks are labeled A, B, and C, and the tension in this string is labeled T1, and the tension in the second string is labeled T2. Now, given that mass of the block A is equal to mass of the block C equal to 5 kilograms, and mass of the block B is double of that, it's 10 kilograms, and G is equal to 10 meters per second square. You have to calculate the accelerations of the blocks, and you have to calculate tensions. So start working on this straight away. So what you have to do here is, everything in Newton's laws is about solving the free body diagram properly. If you have learned from the 4 lectures so far how to make free body diagrams, resolve the forces correctly, then you will have no difficulty in solving any of the questions, whether that is from HC Verma or from my worksheet or anywhere else. You will not have any difficulty in solving these type of questions. Everything is down to making the free body diagram precisely and understanding how to resolve the forces. So make the FBDs of the 3 blocks, please. Start with that, I will explain. Okay, so let's start by understanding the free body diagrams. So I hope you have made the FBDs yourself, so you can just verify from what I made. So for the free body diagram for A, you can see that the forces are very simple. There is the weight of the block. Okay, so now one thing of course is that let's assume A will have a downward acceleration. Then this will have the same magnitude of acceleration along the inclined plane, and this will accelerate up. Now, how I can guess that C is because A and C have the same mass, 5 kg, but then this block in between is on an inclined plane. No? So what dominates is the fact that the block is pulling C up. Okay, so A and B will end up going down and C will end up going up. Okay, so that should tell you the direction of the acceleration. Okay. So the forces on this are these, and it has a downward acceleration of A. So for A, we have the equation weight minus tension T1 is mass into acceleration, which we can substitute as 50 minus T1 is equal to 5A. So that becomes our first equation. Okay. Now similarly, you make the free body diagram for the block B. Now block B is a little bit more complicated. You'll have to resolve the weight. So this will be weight's cos component. This will be weight's sine component. Okay, that to B is weight. Then there is one tension which is acting down the inclined plane T1, another tension that is acting up the inclined plane T2, and of course there is normal reaction in. Okay, so for B, the equation you will have is that T1 plus the weight's sine component minus T2 is the net force along the inclined plane. So that is mass into acceleration. Whereas you'll also have that normal reaction balances the weight's cos component. So of course we'll be substituting the mass of B as 10 kilograms and theta as 30 degrees, whereas mass of A was 5 kilograms. So our equation becomes T1 plus, again this becomes 100 into half. Okay, so that becomes plus 50 minus T2 is equal to 10A. That's our second equation. No, Tej, if you are asking positive negative, that means you haven't understand how we apply the free body diagram equation. See, what is happening is that the block B, इसके acceleration का direction कैसा है? ऐसा है. Whereas what is the direction of T2? It's upwards. So T2 will contribute to negative quantity to net force. What is the net force? It is the force along the acceleration. So what is the x-axis we are taking? This is the x-axis we are taking. So mg sine theta and T1 are driving the acceleration. T2 is acting in the opposite direction. So that is why T1 and mg sine theta will come with a positive sign, whereas T2 will come with a negative sign because it's opposite to the direction of net force. So you have to understand all this by now. Okay. Yeah. Okay. Right. So we got to your second equation, and now for the third one, it's pretty simple really. For the block C, you have T2 upwards, weight downwards, but remember its acceleration is upwards. So we have to take the net force in the upward direction, and mass of C is again 5 kilograms. So tension T2 has to be greater than, that is mass into acceleration. This is telling us that T2 minus 50 is equal to 5A. So that's our third equation. Okay, so I'll just minimize this a little so that you can see the free body diagrams along with the main diagram. And rest of it is about solving. Now, part of the challenge in Newton's laws is also you have to learn to solve simultaneous equations as efficiently as possible. Okay, so simultaneous equations, when you solve, it's all about eliminating variables. So what are our variables? T1, T2, and A. These are the unknown quantities. And what do we have to find out? We have to find A. So we need to eliminate. So we need to eliminate T1 and T2. So when you look at the equation 1, 2, and 3, you have to understand that that's what you have to do. You have to combine the equations in such a way that T1 and T2 get eliminated. Now once you have that in mind, it's quite easy to solve. Okay. Just solve the three equations and tell me the acceleration now. Yes, 2.5 meters per second square. That's correct. That's the correct answer. Yes, so next step is solving the equations, which is very simple. You just add the three equations. You have 50 minus T1 is 5a. That's your equation 1. Then you have 50 plus T1 minus T2 is equal to 10a. That's your second equation. And then again you have T2 minus 50 is equal to 5a. That's your third equation. To find the acceleration, you can just add these three equations. If you add T1, T1, T2, T2 gets cancelled out, and you have 50 plus 50 minus 50. On the other side, 5 plus 10 plus 5 E. So the acceleration, as you can see, becomes 50 by 20 or 2.5 meters per second square. Now, once you got this acceleration, you can put them back in equation 1 and 3 to find T1 and T2 respectively. Substitute this. So from equation 1, your T1 becomes 50 minus 5a. So that becomes 50 minus 5 into 2.5, that's 12.5. So T1 becomes 37.5 newtons. And from equation 3, let's see that T2 becomes 50 plus 5a. So that is 50 plus 12.5. So your tension T2 is as much as 62.5 newtons. So you found out the tensions also. Okay, so hope the answers are clear to all of you. Okay, now next thing for us, the next type of problem, now pay very close attention here, is a situation where we have system of pulleys. Okay. So there is an additional concept that we have to apply in these type of problems, and we'll understand that in just a moment. Okay. So our first example of something with a system of pulleys is like this. So we have one pulley which is directly attached or fixed at the ceiling. like this. Okay. But we have another pulley now, which is going to be attached in a slightly different kind of way. Explain that to you. Now the second pulley in our system is going to be like this. So this first thread is going around this second pulley, and it's again attached to the ceiling over here. Whereas this pulley itself, from the axle, it's attached to a block like this. And of course, we have another block here. So these are pulleys P1 and P2, and these are blocks A and B. Okay. So P1 and P2 are massless and smooth pulleys. Okay. The thread is of course also massless and inextensible. Okay. And suppose given the mass of the block A is 20 kilograms. Wait, pay attention, I'll explain. Okay. So the first part of the question is, if the system is in equilibrium, that is, remains at rest, okay, when released, okay, then what should be the mass of this block? And second part of the question is that if the mass of the block B is 50 kilograms, then find the accelerations of the blocks A and B. Okay. So I'm sure you will be able to visualize this problem, that acceleration is possible. Okay. So what are the possible types of motion? One possible type of motion is that A is very heavy. If that were to be the case, though this is not going to happen in our particular example, but suppose A was a comparatively very heavy block, then what would happen is the block A would force the system to move like this. One possibility is that A could be going down and therefore B could be going up. So after some time, A has reached here, and this pulley along with B attached to it has gone up. So this could be one kind of motion. Or another kind of motion could be the opposite, which is going to happen in our second part over here, that the block B is much heavier. So it is driving the weight of the block B is so much that it's dominating. So then it could be that block B ends up coming down after some time, and as a result of that, block A ends up going up. So this could also happen. So A could have an upward acceleration, B could have a downward acceleration. Or it could be that A is having a downward acceleration, B is having an upward acceleration. Or it could also happen that A1 and A2 are both zero. The third possibility is also there. So there are three cases possible: case 1, case 2, and case 3. And which of the three is happening actually depends on the masses, what kind of masses they are. Have you understood it now, Tej? Okay. So let's start with part 1. In part 1, what we want is that A and B should be in equilibrium. Okay. That means their acceleration should be 0. So let's understand how that is happening. So since it's a massless thread, it has the same magnitude of tension everywhere. Same amount of tension acting everywhere. So for this case, this first part's case exactly, we want that A and B should both have 0 acceleration. So we want that to happen. On both of them, the net force should be 0. So we want this situation, this one's acceleration also has to be 0. This one's acceleration also has to be 0. So that means when we make the free body diagrams for E, should have this, and for B, what is happening is there is a massless pulley attached to it. So that doesn't contribute anything. But on the pulley, there are two tensions acting. So the net upward force is 2T, and its weight is this, and its acceleration is 0. So this is telling us that the tension should balance this weight. And this is telling us that twice the tension should balance this weight. So this is equation 1, this is equation 2. And comparing them, you get, therefore, mass of B should be equal to 2 times mass of E. Okay. So that means in this case, mass of B should be equal to 40 kg. So this is the equilibrium condition. Now, this equation that we got over here, this is the equilibrium condition. Okay, because mass of A was given to us as 20 kg. We wanted to find out the mass of B. So this is the condition. If the mass of B is exactly 40 kg or its weight is double, then the system will be balanced. The way A and B are pulling on the thread will develop a tension of 20 newtons, which will make sure that A's weight is balanced and B's weight is also balanced because the thread is going around that pulley. So the tension acting on the block B is double of the tension acting on block A. Yeah, just look at how B is connected, na beta. The pulley is connected to the block B. So how much tension is acting on the pulley? Thread is going around the pulley, na? So there's tension from both sides. Look at the pulley P2. Is it clear now, Harshal? So that is what happens in a system of pulleys. If the thread was directly attached to A, then the to B, like it is attached to A, then the tension would be just T on B. But because it is going twice, is going around the pulley, so there are two tensions parallelly acting on that block P through that pulley's axle. That is why the net upward force because of this thread acting on B is 2T. Okay. Yeah, Chris is not really required because the same diagram I've shown you over here. So don't worry about the diagram upstairs. Just make sure you understand the first part. Then we'll come to the second part. Don't worry. But the diagram and the data in the above part is the same as I've given you over here. So everything you need is there in this diagram. So just take down this part first. Then we'll understand what's happening in the second part. In the second part, instead of taking the mass of B as 40 kg for equilibrium, we are increasing its mass to 50 kg, keeping A the same, of course. So now you have to understand how that will affect the system. Okay, so now let us see in the second part what is happening. We are keeping the mass of B as 50 kg. So it's going to be comparatively more than what we've got for the equilibrium condition. So then which of these cases is going to occur in the second part? This case is going to occur. B will accelerate downwards and A will accelerate upwards. Okay. So now we come to a more tricky situation because there is a system of pulleys. So the magnitude of their acceleration will not be the same. So let's understand why that happens. Okay. So the second part, we have taken the mass of B as 50 kg and mass of A as 20 kg. So the condition where B will move down, okay, with acceleration, let's say A2, and A will move up with acceleration A1. So this will happen. Now this is where you have to understand very carefully that A1 will not be equal to A2 in magnitude, and let us understand why. So visualize this diagram which I am showing you now. Okay, that this is where they started their motion from. So A was here and B was here. So this is at some time t, let's say. Now after some time at t plus delta t, now because A is going up and B is coming down, let us say in comparison to this diagram, what has happened is that the block B has come down to this position here. Okay. And in comparison to its own position, the block A has gone up here. So A has reached here, B has reached here in this diagram. Okay. So what is happening is that you can see clearly that A has made a displacement of, let us say, SA upwards, and B has made a displacement of SB downwards. Okay. So let us say from some time t to t plus delta t. So in that interval of time delta t, A's upward displacement is equal to SA, and during that same time B's downward displacement, that is equal to how much? That is SB. Now we will find a relationship between SA and SB. Okay. So this is, now there is a certain relation, mathematical relation between this SA and SB, and that thing is called a constraint relation. Okay. So this is a new concept for us. In Newton's laws, this is called a constraint relation. Okay. So how do we develop the constraint relation? This relation comes from the concept that the total thread length remains constant. Okay. So now you visualize in this diagram that, if the block B has come down by a certain displacement. So let's say the block B was here originally. Block A was here. Now if the block B comes down from this position to this position, okay, it comes down by SB. So how much thread it is pulling over here? It's pulling two times SB kind amount of thread. So plus 2SB is the amount of thread length it's pulling from this side. So during that same time, A has to go up by SA, so that how much thread it releases? It releases SA amount of thread, so minus SA. So this has to be 0. So यहाँ से the amount of thread being pulled should be equal to the amount of thread being released from this side. See, in the same thing there is in this diagram also, that going from this to this, if A goes from this position up to this position, so how much thread A is releasing? It is releasing SA amount of thread. But on the other side, B is coming down by SB. So how much thread it is pulling? It's pulling 2 times SB. So the amount of thread pulled by B should be equal to the amount of thread released by A. Okay. So what is happening is, during this displacement, in this time when this displacement is happening, B pulls 2 times SB amount of thread down, while A releases SA amount of thread. Okay. So the total thread length should be conserved. If the total thread length was L, so now on the other side, B has pulled down SB, but A has released SA. So this should remain conserved. So that is what is giving us this relationship, where L is the total thread length. So if you compare the diagram on the left with the right, the diagram at t equal to t, which I made in black. Now in that, the total thread length is L, let's say. Okay. So ये वाले diagram में, so let me maximize this a little more. So in this diagram here, this one, the total thread length, let's say, is L. This total thread length. Now, when you're going from this diagram to this diagram, delta t times later, your block B along with this pulley P2 attached to it has come down by SB. So how much thread it has pulled with it? It's pulled 2 times SB amount of thread. But on the other side, A has released how much thread? SA. So now what your total length is becoming? It is becoming the original total length plus 2SB on this side, but minus SA on this side. And that should be equal to the original length L. So that's how we get this relation, that L plus 2SB, the amount of thread pulled on this side, minus SA, the amount of thread released on this side, should be equal to the original length L only. And that's how we know that 2SB minus SA should be equal to 0. And this is what we call the constraint relation. Okay. So please make a note of this carefully now. This entire part on the right side, make a note of it carefully and make sure you understand this relation, that SA is equal to 2 times SB carefully, and ask me if there's any doubt about it. How we've got this relation that SA or 2SB minus SA is equal to 0. there's any doubt, please ask me. Yeah, tension will remain uniform, Krish, because what is happening? That it's a massless thread. So within one massless thread, okay, so this relationship is clear. No, L is not added beta. Yes, what is happening? L is the total length of the thread. So what I said in the diagram on the left hand side, this first diagram at t equal to t, ये जो total thread length है ना, so just follow my cursor to understand. So in this diagram, the total thread length, see it's from A to the pulley, then going around the pulley, second pulley going around it. ये total thread length ही L है. So in the second diagram, see what is happening. This side, it is becoming decreased by SA, and this side it is becoming increased by 2SB. So whatever total length you had on the left hand diagram, you have added 2 times SB, okay, for the second and third part of the string, whereas you subtracted SA for the first part of the string. So that should be equal to L plus 2SB, what you added, minus SA, what you subtracted. Okay na? So we are just writing an equation where we are expressing that total thread length is remaining constant. So ये जो equation हमने लिखा है, that the original L is equal to that same original length plus something minus something. So what we have added should balance what we have subtracted. So this is just expressing that the total thread length should remain constant. This is the constraint relation, that the total thread length remains constant. This thing is, and then L is getting cancelled on both sides, so we're getting this relation. Okay. So accordingly, now what is the relation we are getting? That displacement of A should be twice of displacement of B. So what does that tell us? That if we differentiate the displacement of A with respect to time, we'll get 2 times differentiation of displacement of B with respect to time. That means at any instant VA is equal to 2 times VB, where VA will be the upward velocity of A at some instant of time, and VB will be the downward velocity of B at that same instant of time. Okay, so now differentiate this once more. So differentiation of VA should be 2 times differentiation of VB. And what is differentiation of velocity? It is nothing but acceleration. So acceleration of A should have a magnitude of 2 times acceleration of B. So this is the relationship between upward acceleration of A and downward acceleration of B. So we started the whole thing by saying that no, they will not have same magnitude of acceleration. So then the question is, what is the relationship between their accelerations? So the relationship between their accelerations is this: acceleration of A will be double of the acceleration of B. Okay, you can just think of it in a simple way like this: that if the block B has come down by 1 centimeter, okay, then the block A will be pulled up by 2 centimeters. So always the ratio is 1:2. So the ratio of displacements is 1:2. The ratio of velocities, which is rate of change of displacement, that will also be 1:2. And the ratio of acceleration will also be 1:2. Didi, the pulley is attached to B, na? See, one pulley is attached to the ceiling, so it is never moving. Okay, so that you can see in the diagram. The pulley P1 is remaining attached to the ceiling, it never moves. Whereas the pulley P2, it's attached to B, na? तो B जितने से नीचे गया है, the pulley P2 is coming down by that much only, na? So that's why this relationship remains fixed. You understanding? So whatever is the displacement of the block B, that is only the displacement of that pulley P2. Have you understood now, beta? So if the block B has come down by 1 centimeter, it has pulled 2 centimeter of thread because the pulley has also come down by 1. So A has gone up by how much? By 2 centimeters. So the ratio of their displacements is always 1:2. जब इसका 1 centimeter इसका 2 होगा. By the time this one is 5 centimeters, this will be 10. So like that, rate of change of displacement with time, velocity, that will also be 1:2 ratio. And therefore rate of change of velocity with time, which is acceleration, that will also be 1:2 ratio. So this process is called the constraint relation in Newton's laws. Whenever we have a system of pulleys, that's a different system. Beta. If both the pulleys are moving, that's a different situation. We will discuss. But this is the first example of system of pulleys where P1 is fixed to the ceiling. So we don't have to worry about P1's acceleration. P2 is fixed to B. So P2 is moving with the same displacement, velocity, or acceleration as B. And then we are using the concept we are using is very simple, that the thread length should remain constant. So later we'll see if we have more number of pulleys, okay, with the thread going around more number of times, we have an equation which may be more lengthy, but the concept will be the same, that the total thread length should remain conserved. So this whole process, it is called, so this final result that we have got, it is called constraint relation. So constraint का मतलब क्या होता है? It means a limitation or some kind of fixed rule. So there's a fixed rule here that their accelerations are in 2:1 ratio. Their velocities are in 2:1 ratio. Their displacements are in 2:1 ratio. So these are all the constraints of the system. Why the constraint is there? Because the thread length is constant. Okay? So that's giving the constraint to the system. That's giving the limitation that we cannot stretch the thread. We cannot change its length as the system is moving. So the constraint is that the ratios is like this. Okay, so this process is called constraint relation by application of thread length conservation. By application of thread length conservation. So there are many different types of constraint relations in physics and especially in mechanics, okay, and many different ways of applying thread length conservation. But one of the methods that we are learning here, the first method we are learning here, is conservation of thread length. Yes, the moment there is acceleration, the moment we are out of equilibrium condition, Chris, that's correct. The relationship between ratio of displacements or ratio of velocity or ratio of acceleration, all three will be 1 is to 2 like this. Or A is to B will be 2 is to 1. So that is the constraint that the system has. And Harshal, to answer your question, like we can have a system with not only 3 pulleys but 5 or 6 pulleys also, and accordingly the constraint relation will change. Okay, so every time we'll have to make a fresh constraint relation by using the thread length conservation method. So for each different type of system of pulleys, we have to develop the constraint relation method. Okay, this is your first example. So this is one which has 2 pulleys instead of a single pulley. And here we are seeing the relationship is working out like this. Okay, now we still have to solve the rest of the problem. So what we've done is, so far we have got one thing, and that is the constraint relation, the relationship between the two accelerations. But we still have to solve for a1 and a2, no? Or acceleration of a and acceleration of b. So how we'll solve? The rest of it is free body diagram. So for this system now, let's say I'm just going to change the names of these two, acceleration of a and acceleration of b. So this one is acceleration of a and this is acceleration of b. So the first thing that we have got is by thread length conservation. Okay, we have got the constraint relation. That's the first equation we have got. Okay. Acceleration of A is equal to 2 times acceleration of B. That's my first equation in the system. So this is coming by, this is a constraint relation, and we have derived this by thread length conservation. Okay. So this is the first time you're learning this, so it seems very complicated, but don't worry, you'll get very used to this soon. Okay, so we'll do many such questions. Okay. Now the next thing is free body diagrams. Okay. So for A, you have the same free body diagram that we had earlier, tension and weight. Okay. But this time the difference is having an upward acceleration. So the equation will become what? T minus weight is equal to mass into acceleration. Okay. So T minus 200 is equal to 20A. So this will become our second equation, which is coming from free body diagram of the block A. And a third equation will come from the free body diagram of the block B. But don't forget the block B has the pulley attached to it. So there is tension from both the sides acting, T and T, whereas weight is downwards and it has a downward acceleration of EB. So for this the equation will become weight is dominating, weight minus 2T is equal to mass into acceleration. So this will become 500 minus 2T is equal to 50 times EB. So this is becoming the third equation of my system. Now, as you would have noticed that there are three variables. There is acceleration of A unknown, acceleration of B unknown, and tension unknown. So we needed three equations, and we got the three equations. Now we have to solve these three simultaneously. But obviously the solving is going to be a little more complicated because this is different accelerations on the right hand side, first of all. Okay. And also here you have T and here you have 2T. So we have to do a little bit more of substitution to solve. Solving these kind of equations are not as simple as the previous examples we saw, where you just add the equations blindly and you get elimination of tension. So write down up to this step, then we'll discuss about the solving. ठीक है people, are you clear with the three equations, how we got them? Okay, now listen to me carefully how we will solve the equations. ठीक है, so देखो equation कैसे solve करेंगे. This equation has t, okay, and this has 2t. So do one thing, take equation 2 and multiply it by a factor of 2. So that is 2 times t minus 200. On the other side, that is 2 times 20 acceleration of a, and take equation 3, which is 500 minus 2t is equal to 50 ab. So now add these two equations. So 2t will cancel out. So you're getting 500 minus 400 on the left hand side. So just twice of this is becoming 50 times ab plus 40 times acceleration of a. And then in this, what you do is you substitute this. Substitute acceleration of A is equal to twice of acceleration of B from equation 1. Yeah, so we'll simplify that. So we'll get 100 on this side is equal to 50 times AB plus 40 into 2. So that is 80 times AB. So that is 130 times AB. So acceleration of B is becoming how much? It is becoming 10 by 13 meters per second square. And acceleration of A is double of that. So it is 20 by 13 meters per second. So, and you can leave the answer in fraction, or you can simplify it as a decimal thing also. It doesn't really matter. It's typically in the questions, the answers of this type of question will be given to you as the options will be in fractions only like this. So 10 by 13 is fine. But if you want, you can solve it further as a fractional thing. So it will be 0.77 almost. And acceleration of E, acceleration of B will therefore be double of this. So 1.54 approximately. These will be your answers. Yes, Krish, that's correct. That's good. Okay. So this is the next level of problem for us, okay, involving pulleys, a system of pulleys instead of a single pulley. So whenever we have a system of pulleys, we have to generate one additional equation. The free body diagrams are going to give us some equations, but they will never be enough. Like, see, we had two equations from FBD and we had three variables now. So one extra equation has to come from somewhere else. So where that extra equation will come from? It will always come from constraint relation. And one of the methods for constraint relation is thread length. Okay, there are other methods and we will learn them also. But the most fundamental method for constraint relation in system of pulleys is conservation of thread length, which we have learned here. Okay, so is the solving part clear to all of you? Finished writing this down? Okay. So let's look at another example. Very good. Okay, good. So see, these questions are initially going to be a little bit more tricky for us, both in terms of solving as well as working out the constraint relation. but we have to be patient and solve a lot of examples, then things will become clear. Don't worry. Okay, so the next example is like this. So one pulley is attached to the corner here. The smooth surface, the block attached like this. Now we have that same kind of thing which we saw earlier. This string, instead of directly being attached to our second block, it is going to go around a pulley, and that pulley is going to be attached to our second block. So that's our second pulley. This is again fixed to some kind of ceiling over here. Now this is again massless pulley attached to block B. So acceleration due to gravity is 10 meters per second square. P1 and P2 are both smooth and massless. The thread is massless and inextensible. So even if you don't see these things written explicitly in questions in HC Verma and all, you have to always assume that they are ideal pulleys and ideal threads. So this assumption is part of it. Okay. Now if mass of A is equal to mass of B, equal to let's say 10 kilograms, find accelerations of A and B. So here the surface is frictionless, so we cannot stop the acceleration in any way. Unless we remove the mass B, A will definitely accelerate. तो यहाँ पे ऐसा कोई केस हो ही नहीं सकता है that there will be equilibrium unless we are pulling A or unless there's friction, and friction will come for us later. And also B cannot be going up unless we start pulling from this side. Okay? So it will always be the case that B is accelerating downwards and A is accelerating horizontally. However, we have to solve for that case where the masses are equal, and we have to also find the tension in the thread. So work this out. This should be pretty simple for you based on the previous question. So what are the steps you will do here? You will first make the constraint relation between the acceleration of A and acceleration of B. That's the first step. Then free body diagrams, and then solve the equations. Same kind of steps as previous question. Okay, so first thing here, can you tell me what is this relationship? Acceleration of E is to acceleration of B कितना होना चाहिए यहाँ पे? Yes, that's correct, Kunal and Punk. That's no, Punk, you got it reverse. Okay, so if E makes a displacement SA like this during the time that B together with the pulley makes a displacement SB like this. Okay. So what is happening? The thread length is increasing by 2SB, decreasing by SA. So the amount of thread released from A's side should be equal to the amount of thread pulled by B. So B is again pulling 2 times SB amount of thread. So A should be releasing SA, which is 2 times SB. Okay. So this will now tell us that acceleration of A should be twice the acceleration of B, or ratio of their accelerations is 2 is to 1. So this is my first equation, the constraint relation equation. And then rest is free body diagram. Now remember that it's a massless thread, so the magnitude of tension will be same everywhere. So, very good, Chris, that's correct. So now you understand the free body diagram equations. So for E you have only one horizontal force. So T is equal to mass of A into acceleration of A. 2AB. We can just directly substitute this here. This becomes our second equation. Okay. And for B, you have 2T upwards and weight downwards and acceleration. So weight minus 2T is mass into acceleration. So 100 newtons minus 2T is equal to 10 EB. So this is even simpler. Okay. So what you now do is substitute this here. So you get 100 minus 2 times T, which is 20 times AB, is equal to 10 EB. So 100 is equal to 50 EB. So acceleration of B will be 2 meters per second square downwards. Downwards, okay. And therefore acceleration of E will be 4 meters per second square horizontally. Horizontally. Yes, very good. That's correct. So hope all of you understood this. Right. Good. So tension कितना हो जाएगा? That's correct. Tension you will get from equation 2. From equation 2, the tension is going to be 20 AB. So the tension is going to be 40 newtons. That's correct. Okay, very good. So that's right. Okay. So I think all of you are clear with this. So we will do one more problem of this type before I will discuss some questions from the workbook as well as the assignment earlier. So the next one now we are going to discuss is going to be a little bit more complex compared to this one. So we have this kind of a situation. Now we are going to have a sort of large size block here, and the first pulley in our system is fixed here. Now a thread will be like this. Yeah, just a moment. I'll get back to you. This is a fixed wall. Okay, so there are three pulleys like this. Okay. And of course, there's one more block attached here. So we have this kind of a system now. Harshal, I'll just take you back. The tension was coming out to be 40 newtons, beta, okay, in the previous question. In equation 1 that you had, na, T was equal to 20 multiplied by acceleration of B. You just substitute acceleration of B and you'll get the tension as this thing. Okay. Okay. So here, all three pulleys are again massless. And smooth. Again, the thread is, because all that standard condition is there. Now, given that mass of B is 5 kilograms and mass of A is 15 kilograms, first of all, find the ratio of this acceleration. The acceleration of A is to acceleration of B. And secondly, find acceleration of A, acceleration of B in meters per second square. So first of all, try to understand the question. This thread is that same piece of massless thread which is first of all attached at this point. One end of the thread is attached at this point. Just follow my cursor. It's attached at the point on the block A. Then that is going horizontally like this around pulley P1, coming back horizontally around the second pulley. Now the second pulley is attached to the block A. So it's going around this, then like this, then around P3, which is the third pulley, which is attached to a fixed point, fixed corner of this floor thing. And then the thread is going around this, and finally the other end of the thread is connected to B. So the two ends of the thread are connected to A and B, but in between they're twisting, thrice like this in between three pulleys. So that is going to make life a little bit more complicated. Yeah, Diti, almost correct, but you have to just be a little careful about the ratio. Okay. Just try to imagine which one will have the larger acceleration, which one will have the smaller acceleration. So you can also understand by thread length conservation that when A moves, A will move towards the right now. So it will release thread and B will pull thread. So just from that, you try to understand that which one will have the larger displacement and therefore the larger acceleration. The numbers are correct, just the ratio we got was reverse. Yes, that's correct now. Good. So if you figured that out, then the rest of the question is easy. Yes, Krish, correct. Very good. So try this out, people. Okay, so very good. Most of you have figured this out. I'm happy that the ratio of accelerations you will be getting is 1 is to 3. No. Acceleration of E will be one third of the acceleration of 3 of B. So let's understand why that will be. Okay. So everything is from the way the string is arranged, because you have to conserve the length of the string. No? So you have to understand it geometrically. Okay. So in this diagram, if after some time what happens is that this block moves like this along with the pulley attached to it. So ये जितना से भी मूव किया, सपोज दिस इज ऐसे, ठीक है, यहाँ पे कितना थ्रेड लेंथ कम हो गया, 3 टाइम्स ऐसे कम हो गया, ठीक है, एंड ड्यूरिंग दैट सेम टाइम बी विल हैव टू मूव लाइक दिस. So the simple way to understand it is this: see, the thread is like this, no? The thread is like this. So you don't even have to think so complicated. You think like this, that suppose this whole system moves by 1 centimeter. So how much thread it releases? For SA equal to 1 centimeter. Okay. 3 centimeter of thread is released. You know? So if 3 centimeter of thread is released, what will happen? B will have to go down. So B pulls 3 centimeter thread. So that means B's displacement will have to be 3 centimeters. So the ratio of their displacements, SA is to SB, become 1 is to 3. Or SB is equal to 3 times SA. Sorry, I've written this wrong. Diti, now this is a different question you are asking. The small block's weight is creating tension in the thread, na beta, and the larger block is resting on a frictionless surface, ना. तो उसका weight तो कुछ कर ही नहीं रहा है, उसका weight तो normal reaction से balance हो रहा है. You understanding the point, beta? In everyday life, you might imagine this doesn't happen, because in everyday life you don't imagine a frictionless surface. No, but imagine this is a polished ice surface, and this is a light, wooden block or polished wooden block. So it will slip easily. No? Even if there's some friction, that friction will be very very small. So even a slight amount of push given to this block A will make it slide. No? So इसका मास बहुत कम भी है अगर B का, ना कुछ few grams में भी है, वो थोड़ा तो tension create करेगा ना in the string, and the moment there is tension in the string, the block A will have to slide forward because there's no friction. Yes, that's why. So the difference is, difference between what we experience in everyday life versus this kind of situation. How we will be able to gauge that difference only by the proper scientific method, which is free body diagram. Now, whatever you think, whatever the illusion is, from your everyday kind of thinking, the free body diagram will tell you the truth. End of the day, it's like that. Free body diagram will make the scientific basis of it 100% clear. What is happening versus what is not happening. Okay, so that's why we have to be very systematic in in our conclusions in questions like this. We have to always rely on the free body diagram only. Okay, so now from this constraint relation we know this is the constraint for displacement. So differentiate this twice, this one differentiate it twice, so you'll get acceleration of B is 3 times acceleration of B. So this is our first equation for our system, constraint relation. Okay, and then of course the rest is free body diagram. So this is moving with horizontal acceleration like this is moving with vertical acceleration like this, Okay, and now just make sure that we don't make a mistake with counting the number of tensions that is acting in each of the free body diagrams. So for the free body diagram of A, you can see the tensions acting at T, P and T. So there's a total tension of 3T acting on it horizontally, whereas the weight is balanced by normal reaction. So that doesn't really matter. Okay. So our second equation will be coming from this, that 3T is equal to mass of A into acceleration of A. Okay. So 3T is equal to 15 kg, I think was the acceleration of A. So this is our second equation. Okay. And now look at the free body diagram of B. In that there's only a single tension acting and weight, and it is having an acceleration like this. So for this one we have the equation weight minus tension is equal to mass into acceleration. So we have 50 minus t is equal to 5 ab. So this is our third equation. Yes, Harsh, I think your answers are correct. I'll just give me a moment, I'll verify them. Okay, so let's put together the equations we have so far. So we have equation 2, which is telling that 3t is equal to 15 times acceleration of A, or we can say t is equal to 5 times acceleration of A. Okay, now substitute this in equation 3. So we have 50 minus t. Now t is how much? 5 times acceleration of A is equal to 5 times acceleration of B. And now from your first equation, again substitute from equation 1, acceleration of B is 3 times acceleration of B. So this will give us 50 minus 5A is 5 times 3. So 50 will become 20 times acceleration of A. So acceleration of A we will get 2.5 meters per second square horizontally like this. Okay. Whereas acceleration of B will become 3 times that, or 7.5 meters per second square. That will be vertically downwards. Very good. So this is like, a more complex type of problem now, because we have more number of pulleys. So you will see that most of the problems in HC Verma are easier than this. They are up to 2 pulleys and you can handle them quite easily. But yes, and for the JE advanced level, we do need some questions which are more difficult, like this one. So this is a JE advanced type of question in Newton's laws. So this could actually be a problem in JE advanced, because Newton's laws is a very important chapter for JE advanced. Vectors, you will not get direct questions. Vectors, the questions will be indirect, like we are using vectors for resolving the forces and things like that. But this chapter we are doing, if you start looking at previous year JE papers, you will start recognizing some of the questions which are directly Newton's laws. And JE advanced, the question will always have some kind of twist, and one of the ways of twisting the question is by constraint relation. Okay. So first of all, it requires patience to be able to work out the constraint relation from thread length conservation. So that is something you have to practice. Okay. In fact, by the time you complete HC Verma's exercise itself, you will have more than enough practice that you require for constraint relation. But of course, we will be doing more questions also. The module is also there, plus more assignments. So you'll get plenty of practice. And then of course, once you got the constraint relation right, there's one more thing. You have to solve the equations also correctly, because you now the equations are not direct. You have simultaneous equations with number of variables. So elimination, solving, this part also becomes important. So many times students are good at writing the basic equations and applying the physics, but then when it comes to solving the equations mathematically, they tend to make careless mistakes because they're in a hurry. That is a tendency you have to avoid from the beginning. Don't be in a hurry. If you are very slow at solving problems but you are accurate, you will gain speed with practice. But if you start making careless mistakes from the beginning, you will take a lot of time to start, removing those mistakes from your system. So if you're fast and this thing, fast and inaccurate, it's going to take a lot of effort to make you accurate. On the other hand, if you're slow but accurate, the slow will become fast with just a bit of practice. So that's why my advice is that while doing the exercises, don't worry about whether you're fast or slow. Yeah, creation in NEET, there will be up to two pulley kind of systems. Like this example which I've shown you, this is more a JE type of problem. But the previous two examples, those are the typical type of questions you can expect in NEET. And if you get that book, that DC Pandey for NEET, Physics for NEET by DC Pandey, you will have plenty of questions in that. Yeah, not directly by counting the number of threads. Okay, but yes, there is a second method also, which is called virtual work method, which we'll be discussing in the next lecture. So in certain cases, that second method will be shorter than this. Okay. In certain cases, that second method will be easier, virtual work method. But you should know the basic relation here also, the thread length conservation. You should know the fundamentals. Okay. All right. So that is about this thing. Now I want to discuss some of the questions from the workbook, especially. Okay. So I'm just going to select some of the trickier questions which I want to discuss first. Okay. And then if any other questions you wanted to discuss I have not covered, please just contact me by message or whatever, and I'll help you out with those questions also. So from workbook 1A, the free body diagram one, I will select some of the examples which I think are tougher. Okay. So the first one I'll select is example J. So example J was like this. They have apparently a vertical wall and a smooth floor and some kind of a block. Now remember, in this workbook, I'm not asking you to solve for acceleration or anything. You just have to make the free body diagram. The only thing I'm interested in is the forces. How many forces are acting? What are the forces? And what are their directions properly in the free body diagram? So this is the thing. Okay. So smooth surface, smooth flow. Oh, sorry. This is key. Okay. I'll come back to J. Both these ones I want to discuss. So just fortunately I made the diagram of K first. Okay. I'll come back to J. So this block is of mass m. So now when we see that here there will be a contact force acting on it like this. So let's say this is NA. So this is the wall, this is the smooth wall. So NA is the normal reaction applied by the wall. And this is a smooth floor. So this will apply a normal reaction like this. It will be at 90 degrees to this surface. This will apply at 90 degrees to this surface. So this will become a horizontal force. That is the important thing. And similarly, NB, let's say, this will become normal reaction by the flow. So this will become a vertical force. So when we make the free body diagram of the block, we'll represent it by a particle. So the forces that we will show on it will be these three: weight, one normal reaction horizontal, one normal reaction vertical. Okay. So this will be NB with NE. So this is the only thing I'm looking for in this test. I don't want any more solving in this. This is the free body diagram. So that's all you are asked to solve for. Okay. Now, of course, here what will happen is this block will not be at rest, so it will be sliding like this. So as it is sliding, it will have some kind of an acceleration like this, because this will be coming down like this. Okay. This point of contact will be sliding like this, and this will be sliding like this. So it has a complex kind of acceleration. So we can't balance the forces. So that is a different thing, how we will relate the forces. But here I was looking for only what the forces are and what are their directions. So these are the forces. There are two vertical forces, one upward, one downwards, and one horizontal force. So hope this is clear, people. Okay. Now the other one is something little bit of a variation of this. So what is happening in that is the option J. So it's like, we have like a corner point on the wall like this. Again, this is all smooth. That corner point is also a smooth point, and we have a smooth floor. And now there is this rectangular wedge or block or whatever, which is resting like this. So this is how this question is now different compared to the other one. There it was resting on the wall directly. The corner of the block was resting against the wall. Whereas here what is happening, the block's surface is resting against the wall's corner. That's the difference now. वहाँ पे इसका कॉर्नर वॉल के अगेंस्ट था, और यहाँ पे वॉल का कॉर्नर ब्लॉक के सरफेस के अगेंस्ट है. दैट्स द डिफरेंस बिटवीन दैट. So at this point what is happening, this is the plane of contact. So the normal reaction that this guy will be applying will be like this. It will be along this kind of direction. The normal contact force will be along this line. This is the perpendicular line. Be along. So this is how this normal reaction will be acting. So let's say this is N1. Whereas the normal reaction that will be acting at the other corner point, hey cookie, no, get down. Just a minute, guys. Cookie. Yeah. So the normal reaction that this will be applying here, the floor, which will be in this sort of direction. Okay. And of course, the block is having some mass, so there will be weight. So the free body diagram will be like this. There will be weight acting vertically downwards, normal reaction N2 acting like this, and there will be this normal reaction N1 which will be acting like this. So N1 will act perpendicular to this line. So N1 will act like this, where this angle is theta now. So here this angle is theta. Okay. So therefore you can see this angle will be theta. So hope this is clear, people. Okay, rest of the free body diagrams I think should be clear enough. So if any of you have a doubt in the free body diagrams, you can either send me a message and I will send you a hint or two, or during the mentorship session or doubt session next time whenever we have, we can discuss in detail. Okay. But I think the remaining free body diagrams are straight out of the type of questions we've been doing. Okay. Here also the block will be sliding, so it will have a complex kind of motion. It will have an acceleration in some sort of direction like this, because this point is sliding like this and this point will be sliding like this. So it has that very complex motion. So we won't get into balancing the forces. We won't get into writing F is equal to ma. It's just about what the forces are and what their directions are. So three forces, two of them vertical, and one will be at theta to the vertical. Okay, like this. Because forces balance नहीं कर पा रहे ना बेटा, friction है नहीं कहीं पे. So just imagine this: if you keep a brick against a surface like this, where again there is no friction on the floor. If this is an ice floor, it will have to slide, na? You won't be able to balance. It's only friction that can make it balance. And that again you can see in the free body diagram. N1 का जो horizontal component है, there's no force to balance it, na? So it has to start sliding. Okay. Now, is there any question from the assignment one which is pending for you people? You haven't got the answers, or any question from assignment one? This was worksheet one. Yeah. There are a couple of questions which I want to discuss, but first I want to see which are the questions you haven't got the answers for yet. For example, the 8th and 9th question. So the 8th question is like this: you have a combination of blocks on a smooth horizontal surface. This one is 3 kilograms and this one is 2 kilograms. We start pushing it with a horizontal force of 5 newtons. So we want to find the acceleration, and we want to find n, where n is the contact force between the blocks. So I'm sure many of you would have done this question, but I just want to illustrate a fast way of doing the problem. So if this is block A and B, the first thing you have to understand is that A and B move together, okay, because they will be in contact. So suppose they move together with common acceleration E, then to find A, what we can do is we can make a combined free body diagram. Treat A plus B as one object. So make a combined free body diagram. So if you do that, that combined free body looks like this kind of a body, which is A plus B. So it is having a total mass of 3 plus 2, 5 kg. And on that we are applying a horizontal force F. There's a combined weight of mg, and there's a combined normal reaction Na plus Nb, which the floor is applying. And this system is having an horizontal acceleration E. So F will become this combined mass into acceleration, or F will become mass of A plus mass of B into acceleration. So from that you will get the acceleration as 1 meter per second square. Now once you got this acceleration, you can make the individual free body diagram of either of the two, and from that you will get the contact force. The origin of force, okay. It's saying that somebody is pushing this block, na? F is applied by a hand which is pushing that. Oh sorry, the masses are 2 and 1, is it? Okay. So make a correction there. Okay. So 2 kg and 1 kg. So this acceleration will become different. This will become 5 by 3 or 1.67 plus 1 kg. Okay, so this 5 is equal to 2 plus 1 into a. So the acceleration will become 5 by 3 or 1.67 meters per second square. That's good. Okay. Now, what is the origin of this force? Some external agent is applying force. Huh? Yeah, I'm coming to that part C. But before that, let's calculate B. No? What is the acceleration of the system, and B we have done. What is the hmm. So origin of the force? So for that only we have to understand the 1 kg block's free body diagram. So now understand the individual free body diagrams of the block B and the block E. So block A को क्या कर रहे हैं हम यहाँ से push कर रहे हैं with the force F, okay, and A was against B ना. So when we push this with the force F, A would push against B with a contact force N, and B would push back on A with a contact force N. So this N over here is a normal reaction contact force, okay, between the surfaces of A and B in contact. So it is which type of a force? It is a contact force. Na? So what is the origin of a contact force? Origin of contact forces is always intermolecular in nature. Na? It is one set of molecules pushing against another set of molecules. So it is intermolecular. So that means it is basically what type of force? It is electrostatic force. Because at a molecular level, what is the interaction happening via? It is happening via the charged particles within the molecules and atoms. So the origin of the force at the fundamental level is electrostatic. Whereas when we talk about weight, the origin of the force is gravitational. It's because of mass. So that is what they meant by the origin of the force. Is that point clear? Okay. So now we know that this guy also has a horizontal acceleration. A. This guy also has a horizontal acceleration, and of course, weight of this one is balanced by the ground's normal reaction. Okay. So for the block B, you can see that N. So this becomes the answer. Hmm. So that is part C, na? Net force on A. So net force on A is very simple. Na? I've shown you all the forces acting on A. Now what is the net force on A? For A, F minus N is mass of A into acceleration. So this is only the net force. This is the net force. Net force is mass into acceleration. So how much is the mass? 2 kg into the acceleration, which is 5 by 3. So it's 10 by 3 or 3.33 newtons. So this 3.33 newtons, which is F minus N, this only is the net force. This is the net force on the block E. So that is the C part of the question. This was the B part of the question. You understood? Okay, now very quickly about question 9. So question 9 actually you can do by component method also, or you can do by this thing also, by vector addition by triangle law method also. You're applying a force of 20 newtons in this direction, and then the second force you're applying is in this direction, F2, which is also 20 newtons in magnitude, but this angle is 30 degrees. So the net force is the vector sum of F1 and F2. So the magnitude of the net force will become mod of F1 plus F2. So you can see that F1 and F2 are like this. The angle between them is 120 degrees, and each of them is of 20 newtons magnitude. So you can use triangle law, square root of 20 square plus 20 square plus, or you can go with the rhombus theorem. We had seen that F1's magnitude is equal to F2. So F net will become 2 times that F into cos theta by 2. So you can do that also. 2 into 20 into cos 60. It's 20 newtons. If you calculate this also, this will come out to be 20 newtons. Okay. And the direction of the net force will be like this along the bisector. So that will be the direction of the acceleration. The acceleration will be net force divided by mass. So 2 meters per second square. And the direction of the acceleration will be such that it's along this bisector line. So this angle is equal to this angle, 60. So the block will end up accelerating like this at 2 meters per second square, where this angle will be 60. Okay, people. So hope this question is also clear. This was the ninth question in the assignment. And then the last few questions were about differentiation application, which I told you. Okay. So those are a little bit different. More than Newton's laws, it is about application of the fact that rate of change of velocity is acceleration, and things like that. So use the differentiation principle. dv by dt is a, or if a is given, then velocity is integration, that kind of thing. So if you have difficulty with those questions, again let me know. Okay, but more importantly, now start doing questions from HC Verma. Okay, as soon as possible, start doing questions from HC Verma. We have to complete HC Verma within the next 2 weeks for Newton's laws chapter. Okay, so work accordingly. We will discuss some of the questions from HCV also next time. So that's it for today's class, people. Wish you all the best.